Okay, welcome, good morning. This is the last session, and today we are going to talk about SDA and SD-WAN and how to bring it together. My name is Marcin Kazimierski, I'm Principal Engineer in CX in Krakow, and on a daily basis I support both SDA and SD-WAN and the integration itself. In case of any questions, please reach out on WebEx Teams. There will be, this room is going to be open for the next few days, so yeah, the topic is quite complex. So feel free to, to chime in and let me know what kind of additional questions or concerns you have. The plan for today is the following. First, I will kind of level up on our understanding on what's SDA and what's SD-WAN. Next, I will tell you a little bit more about supported designs. So what we can do with these two solutions and how we can connect them together. Following, I will discuss independent domain and integrated domain. These are the two main ways how we can connect these two solutions together. And the last but not least, I will finish on network troubleshooting. I will show you how to deal with the problems in this kind of integration and how you can solve them by themselves. Okay, so let's start. But before going into the basics, I'm just wondering how many of you have SDA or know SDA? Can you raise a hand? Cool, like half of the guys. Cool. And what about SD-WAN? So, yeah. A little bit. Cool, almost good, yeah. Perfect. So let me quickly go through the basics so that we understand the building blocks of both solutions, and then we'll start to double-click and deep dive into that. So if you think about software-defined solutions, we are talking about the software and we are talking about the networking and the hardware. So from SDA perspective on the software layer, we are having DNA Center. This is the main orchestrator that basically allow us to configure and manage access network. And then we have also integration with ICE. And this is our security engine that will provide, in this case, all the security policies and the way to tighten it fully from security perspective. This is the software. If we now move to the network, we're mainly talking about catenate case, although we support also other devices. And these devices are going to act differently depending on the role we are going to configure it from DNA Center. So these devices could be like SDA borders, so that would be our point of exit to the external world. We are also having SDA control planes, and that's going to be the devices which basically manage the whole fabric. This is the main brain of the solution. And we have SDA edges, which are basically the devices to which we are going to connect all the endpoints. So it's a relatively simple construct, software, network, a few different roles in order to make it all together. So that's the basics of SDA. If we now move to SD-WAN, you will see that the concept is very similar. Again, software and the network. On the software perspective, we have a few more controllers. So we have vManage, we have vBond, we have vSmart. All of that kind of connected together in order to provide this orchestration for one area. So we have vManage, which basically provide this management plane, like day 1, day 0, day 2 operations. We have vSmart, which basically push the policies downstream. And we have also vBond, which allow us to bring devices into the solution, into the fabric itself. On the network layer, here we have just one type of the device. We are having routers. In SD-WAN, we were talking about switches. Here we are talking about the routers. And our C-Edge are basically are going to be the main data plane device, which will allow us to do forwarding from one side to the other and connect branches together and forward the packets based on some kind of policy. So if you take a look and compare both solutions, there are like very common points. So we are talking about the software-defined solution. So we have software network. We have a little bit different protocols used from control plane perspective, a little bit different protocols or stack used from data plane. But we do have this kind of overlay. Yeah? So we have the software, and on the bottom, on the network layer, we have the underlay, being either based on airlock, so root locator when it comes to SD-WAN, or based on the T-lock when it comes to SD-WAN. And then from overlay perspective, we either use VXLAN or we use IPsec. And you will see how all the elements will start to fit together when we go and start to discuss the details about the integration. But before going there, let's see what's supported. Yeah, it's kind of important to understand what we test and what we support, because if you go sideways, then yeah, there could be some issues, and we don't want you to go into areas which are not fully explored. But before going there, yeah, you may ask why you should bother. Yeah, why you would like to connect SDA with SD-WAN. Yeah, what's the purpose? I would say the big why is you would like to have security. Yeah? You would like to connect users with the applications in the way that you can provide end-to-end security. And that's the main, I would say, goal. If we double-click on this one, we are talking about micro and micro segmentations across the whole enterprise. So it's no longer a single site which we manage. Now we have a lot of branches, we have HQ, and so on. We are trying to assure security is end-to-end, and it's kind of working flawless without issues. And we would like to have consistency around it. So the groups that will be added on one branch, it will follow basically and go to the very last element on the network. We would like to have some kind of intelligent routing coming from SD-WAN. We would like to have automation coming from SDA, and so on and so forth. So if you think about what we propose from Cisco perspective around connecting these two worlds together, we have two main designs. The first one is called independent domain. And this is where basically we keep both solutions quite independent. Yeah? The only thing we are kind of doing is this manual config that we do, I would say, between SD-WAN border and SDA border. And you will see it's kind of relatively simple, but it's manual process. Yeah? So it's not something we fully automate. You will need to do a bit of manual steps in order to stitch these two solutions together. There are some advantages of this approach as well. It's quite popular for many customers, but there are also some disadvantages. Yeah? You need to do it manually. You don't have fully integration from controller's perspective. You can see they are not connected yet. And that kind of creates additional, I would say, disjoint from the monitoring perspective and so on. But from simplicity perspective, this is the simple. Yeah? This is the easy way how you can connect these two things together. The second solution we have is integrated domain. So here, basically, we are taking these two, and we are kind of connecting them together on one single device, right? So on previous slide, you had like separate SDA border and separate SD-WAN border. Right now, we are kind of taking these two physical devices, and we're kind of merging them together. In addition, we also connect the orchestrators on the top. So it's no longer like on the previous method that I would say the brains were kind of disconnected and we just connected manually on the network layer. Here we connect basically everything, including the device. The hardware itself is kind of acting both in SDA and SD-WAN, and we're connecting the orchestrators as well. And going forward, I'm going to show you how to configure and then how to troubleshoot both of the solutions, yeah? So that you can pick and choose which approach is best for your specific use case and where you can use it. And the good thing is that you can, on some of the sites you can do one solution, on the other sites you can do the other solution, because there are like some good things and bad things about both of them, which I'll cover in a minute. So let's go now to independent domain. So the simplest, this kind of manual approach, right? So as mentioned, controllers are not connected, so they don't know about themselves. So SDA is not aware of SD-WAN, and SD-WAN is not aware of SDA. The only thing we do, we cannot do manual config, and this is going to be done in order to connect the security constructs together and allow this kind of smooth passage of the HGT tags, in this case, throughout the whole site. So generally, whatever security tags will be here, added by the desktop, through this manual configuration, basically they will flow through the whole up to this IP phone on the right. So basically that's the idea, so that you can enforce the security, not only on site, but among all the sites that you have out there. From interoperability perspective, we are talking here about, like from SD-WAN perspective, SD-WAN borders are going to just act as SD-WAN devices. C edges are going to be fully managed and provisioned by SD-WAN elements. And similar SDA. Yeah? SDA is going to be fully independent. The only thing is that security details are going to be carried over end-to-end through data plane. And data plane, here we are going to talk about Ethernet, about VLANs and Cisco metadata frame. And I will show you in a minute how exactly it's going to look like. So if you think about the solution, the main characteristics is that, first of all, this solution is very flexible, yeah? Because these two solutions are not integrated yet. You can have dedicated teams to manage one solution, dedicated team to manage the other one. You don't really bother about the software versions on one and the software version on the other, because you just do the manual stitching in between. Also, you can do it, you can implement it on the new and existing sites. So if you have existing SDA fabric, you can just connect it and it will work. There will be some limitations when we talk about the next approach, where that will be only for the new sites. The main disadvantage of the solution is that you need two devices, right? So you have like SD1 border and SDA border, so two physical devices. So from cost perspective, if you think you need to buy two boxes, if you have a lot of branches, yeah, it can be quite expensive, right? So that's why the main use case for this is HQ and large sites, because in this kind of deployments, yeah, probably you can bother about having additional devices, and you would like to have all the flexibility out of it. And having two additional devices on the large site is not a big deal. If you have like 5,000 branches, having like extra 5,000 devices, that's probably a big deal, right? So this solution is mainly used in independent domains, and it's going to look like as following. So let's take a look at HQ. We have endpoint, we have SDA edge connected to the SDA border. We have SD1 C edge. And I would like to show you how exactly data plane, control plane, and security plane looks like. So here, basically what will happen, we'll have like IP packet that will come to SDA. From SDA perspective, we're going to kind of uplift it. We will put it into VXLAN, and that will forward as usual in SD1 world. It will get to the border. On the border, we'll have this kind of manual config that I will discuss in a minute. And on the border, we are going to add 802.1q for the VLAN. So we're going to pass the additional information about the VLAN. That's one information that will stitch these two solutions together. But the more importantly is Cisco metadata. Yeah? So this is the additional header that we add in order to pass the information about the security tags. And then when the packet will go to the SD1, generally, like standard approach will happen. We'll take this header, so I can rewrite the packet. We're going to decapsulate this extra headers. We'll can encapsulate it fully in SD1 solution, which is IPsec and so on and so forth. And I will show you details in a minute, so you will see exactly how the packets look like when they traverse step by step through the whole solution. So that's data plane, right? If we move next to the control plane, I would say it's relatively simple. SDA is Lisp, so we are going to use Lisp. SD1 is OMP, and we are going to stitch them together through BGP. So this is yet another protocol that will be introduced in this kind of interconnect between the border of SDA and the border or C edge from SD1. From security plane perspective, the packet, initially the device will get the tag through .1x map. There could be static assignment, things like that. So there will be some kind of tag, security tag, added here on the ingress of the SDA. This tag is going to be carried over through VXLAN, and then the packet will, sorry, not the packet, but the tag itself is going to be rewritten. It's going to be added in this Cisco metadata frame. And then as soon as it will get to SD1, it will be added into IPsec. And that's the way how we basically can assure that the tag will flow end-to-end from SDA through SD1 to the other SDA. In practice, this is how the packet is going to look like. So this is SDA, yeah? And this is VXLAN. In VXLAN, we have VXLAN header. VXLAN header will have segment ID, which is basically the place where we're going to store like security group tag. And VXLAN header also has VNID, yeah? And this is our VRF for macro segmentation. So this is encapsulation from VXLAN perspective. As you can see, we do carry both of the values, yeah, from micro and micro segmentation. So we carry information about VRF, which is VNID, 24 bits, and we carry information about SGT, yeah, which is our security tag for micro segmentation. If you take a look at this kind of stitching that we do in between, Cisco metadata frame, this is how the frame is going to look like. Yeah? So Cisco metadata, VLAN information. So VLAN is only 12 bits. So we kind of lose, because previously it was 24. If you take a look on previous slides, here VNID was 24 bits. Yeah? Here we are talking about 12 bits. So we are kind of losing half of the space. But only, in typical deployment, that should be good enough. And then in Cisco metadata, we'll carry the information like SGT value natively in the frame itself. And this is how we are going to kind of pass information about micro-segmentation and micro-segmentation through Ethernet Cisco metadata header. And then as soon as the packet will reach IPsec, it will again remove some of the headers, add additional ones. It will add IPsec, MPLS label, metadata header, and so on and so forth. Long story short, there is also field there, which is VPN ID, that you know from SD1, VPN 10, 20, whatever. And there is also information about SGT. So we can basically carry and hide this information into the packet itself in SD1 itself. So if you put it all together, basically, you have a way how you can get from SDA through Cisco metadata to SD1. And this is the way how all of these headers basically go through one-to-one. Yeah? Yeah, I will show you in a minute. Yeah. So the question was, how to do it. This is still theory. I will show you the details in a minute. Yeah. But this is the idea, what we would like to achieve. Yeah. We are not doing anything on the software. We are trying to just stitch it on the data plane perspective. Yeah.
Do I need to have higher empty between the board and the SD1 device because of the?
Yeah. So yeah, even here. True, you need to basically take into account these additional headers that will be added on top of, I would say, traditional packet. Yeah. Cool. Yeah.
Does it support only VRF level segmentation, or is the micro-segmentation also supported?
Yeah. So VRF is going to be through the VLAN and VNID to VPN ID, I would say. That's macro segmentation, VRF. And this is micro-segmentation, SGT. So you can do both. OK, so let's see how in practice we can put it all together. So requirements in order to make it happen, generally you need to build SD1 and you need to build SDA. Yeah? Because initially you need to build both, and only then you can kind of put it together. So what does it mean? Generally, this is something that we are going to build. I put some IPs and so on, but the main focus area is going to be this integration area here. You can see this is going to be trunk. We're going to pass some of the VLANs. On the other side, basically, there will be VPNs from SD1 perspective configured here. Sub-interfaces so that we can match the VLANs on both sides. And we also enable here the Cisco metadata, yeah, to pass this information about the security tag. And then the mapping itself is kind of something that you'll need to do manually. So generally, you need to do, OK, this VN from SDA perspective is going to be matched to this VPN from SD1 perspective. So what's the pre-integration state? SDA is fully established. We have devices. Here, I'm just having 2 devices. So I have like one border, one edge. Everything is good, both reachable, both managed. I have fabric, so one device is acting as a control and a border. The other is acting as an edge. Again, nothing fancy here. This is traditional SDA. So this is the way how you configure SDA. Yeah, you put one device as an edge, the other, for example, as a control and the border, and life is good. From the way how you are going to connect this together, we recommend IP transit. So this is the way how from SDA perspective you can go out. So it will automatically configure, for example, BGP for you. It will create the VLANs and so on and so forth. So I would say this is the way how you're going to go out from SDA to SD1. And you will do it for each and every VN, right? So if you have like underlay, overlay in SDA, you basically create like sub interface, BGP session, and so on, everything from SDA perspective, in order to get this part ready towards SD1. Still very standard, nothing fancy here. It's not yet anything SD1 specific. From SD1 perspective, again, everything is standard. You just have, in that case, I have one device. You can see it's control up, so it's connected to the orchestrators. This is standard process. I have some basic templates, VPN 0, interfaces, services, and so on and so forth. Again, this is the way how you do SD1. Nothing specific here when it comes to the configuration and an integration of these two pieces together. Okay, so let's see now how to do the integration itself, yeah? Because so far I said, okay, SD1 is you do it normally, SD1 do it normally. Let's see how to make it happen and connect them together. So from SDA perspective, we are talking about this kind of interface in between, right? So what you need to do, you need to enable this, coming back to the question, how you can configure it. This is the configuration that needs to be added. So generally, we are just talking about 2 lines of CLI on this interface towards SD1. You can see we basically enable Cisco TrustSec. That will enable this Cisco metadata frame and encapsulation going forward. And we configure the static SGT2. This is the value we recommend. It's not that this value is going to be used for each and every packet. This is the value that's kind of, in ICE. If you go to ICE, it's called like TrustSec devices. We use it by default. But generally, all the frames that will go from SDA, it will still propagate the SGT values, right? So you don't really care about this too. I would say this is something that it's there just to configure it and make it working. But long story short, all the tags that will be added here on the left from SDA perspective, they'll be now propagated thanks to this command towards SD1. So this kind of is very simple. It's just 2 lines of code. You can use templates. You can use manual CLI to make it happen. Yeah.
So this second command is just for imposing the tag for local generated traffic as well?
Yeah, okay. As well. Yeah. But it will also, these 2 lines will also allow us to assure this, whenever the packet will come in VXLAN, this decapsulation and encapsulation into Cisco CMD can happen. Yeah, true. So that was SDA part. Yeah, so just 2 lines of config, you're good to go. From SD1 perspective, more or less the same story. Here you need to configure, templates for BGP and for TrustSec. Yeah, so 2 things. For BGP, so you need to have services. Yeah, I created here the mapping, so you can see like VPN 10, 20, 100 for for specific mapping to SDA. So that's this kind of VRF or VRF mapping between VPN ID and VN ID, so that we can do it from macro segmentation. So some basic templates that I can push, so that I will know, okay, this VLAN is coming from virtual network A in SDA, and it's going to be mapped to VPN 10 in SD1. This kind of stuff. Because we are going to use BGP, we need to enable it. Yeah, so we need to advertise, go to advertise OMP and select BGP from the list, because as mentioned before, BGP is our glue to connect these 2 words from control plane perspective. And then you need to configure BGP and TrustSec. Yeah? So here you can see a lot of templates. Of course, you could kind of minimize the number of templates. I just was kind of going for each and every interface separately here, so that I can show you exactly what's the idea here. Generally, you can use variables and make it simpler and smaller. But the idea is that you will configure BGP facing SDA, and then you'll also configure Cisco TrustSec. Because you configure BGP, you also need to assure there is mutual redistribution between OMP and BGP from SD1 perspective. You would like to send all the routes from SDA to BGP and then to OMP and then the other way around, right? So it needs to be kind of in sync. So that's something that you need to assure. And then from trusted perspective, you also need to enable the same kind of logic from SD-WAN perspective. Yeah? So you'll go there, you'll basically select, in the template that you would like to enable propagation, you would like to propagate the tags, and the tag is going to be again value of 2. So more or less the same story. As you can see, it's not very difficult to configure the integration, because that's basically it. Yeah, you do 2 lines of code on SDA, you do like 2 additional templates on SD-WAN, and you are good to go. You are fully integrated. How to check it? Basic stuff. I will cover the troubleshooting in a minute in much more detail. But of course, BGP needs to be up and running, so you can check the prefixes. That BGP, basically, from control plane perspective, we're good. So you can check, that BGP is established. It exchanged some prefixes between, VRF and VRF on SDA and the VPN IDs on SD-WAN. And then you can check also that from Cisco Trusted perspective, from the Cisco metadata, everything is enabled. It's kind of, the status is succeeded. Basically, all connection is done, so that you can be assured that the packets are going to be encapsulated in CMD header. And basically, that's more or less it. Recently, we introduced one additional thing. I will talk in a minute. From SD-WAN perspective, you can also validate it from UI itself, from vManage. You can check that all this propagation and so on is configured and it's up and running. And that's it. Yeah, for independent domains, it's as easy as having 2 CLIs on SDA perspective, or like 1 template to push it, enable Cisco TrustSec, and on SD-WAN is just 1, 2 additional templates, and you are good to go. Yeah. No. At this stage, we are not doing anything on the controllers. Everything is kind of done on the data plane, on the devices itself. And SD-WAN itself, it will just propagate the tags. Yeah? It will not do any enforcement, anything. This stuff that I just showed to you allow us only to take the tags and propagate it end-to-end. There is nothing extra that is required from SD-WAN perspective, because here the assumption is that we have SDA, SD-WAN, SDA. So the enforcement will happen on SDA at the end. And the tags and everything will come from ICE, I would say, to SDA word, not to SD-WAN. Yeah, you can have stuff in between, assuming like this CMD frame will be not touched, yeah, and will be propagated correctly. Yeah. Yeah. The mapping is basically so from SDA perspective, this is where you do the mapping. So you can see the mapping. This is between the virtual network and the VLAN. So this is handing towards SD-WAN. And then on SD-WAN perspective, this is where you're going to do it, right? So you're going to create this sub-interface where the VLAN needs to map to the other side. Yeah, true. I'm not showing here the numbers, but generally, for example, for this infra VN, I used the VLAN which was corresponding like 2100, for example. Yeah. 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 I can show you. Yeah. Later on. Yeah.
The manual configuration needed on the border node, is it a specific SGT number 2? So if I want to use more than 1 SGTs, then I have to do it in a list, or?
No, we recommend number 2, and this is only, I would say, to fully enable the feature. Oh. This 2, it doesn't really matter, I would say, at the end. This is just to fully, I would say, enable feature from the border perspective. Yeah, yeah. And then, it will pass whatever HGT will arrive, and it will just, forward it further. Yeah. Yeah.
Do you have plans to support any other peer reductions back-to-back or like EVP and VPS LAN, so you would only have to have one PGP session with multiple support?
Yeah, EVP and so on, there are discussions happening to have it one day. Yeah, but it's not yet there, and kind of we are talking here. Yeah, there are some discussions. Yeah. Okay, let me quickly check the time. Okay, so let's move forward to, that was independent domain. Let's move now to integrated domain. So here we are talking about interoperability. So here, SD1 is going to perform both SD1 and SDA. Yeah. So we are going to have just one device that will basically do it all, right? And then the device itself is going to be provisioned from vManage. But in some cases, DNA Center is going to send the information to vManage, and then vManage is going to push the SDA specific configuration on the box. So it's a little bit more complex, I would say, from this perspective. The full configuration is going still to be pushed by vManage, but Cisco DNA Center through APIs will be able to instruct what's SDA config on the box. And from SDA perspective, we are talking about single device, right? So this device is going to be fully managed and provisioned by Cisco DNA Center. So I will show you in a minute how it's going to look like exactly. It has a lot of limitations, I would say, this approach, because first of all, you need to assure the versioning is good on both sides. Yeah, so we have compatibility matrix that will tell you, because we are talking just one single device, which will have two functions. We need to assure, the version is being fully tested from one, I would say, solution as well as from the other. Yeah, so there will be some kind of constraints coming from this perspective. The good thing is that it's going to be one single device, right? So that's the main benefit of this approach, that we are going to have one single device. Common use case, very small, a lot of small branches, right? Because you don't want to buy two devices, you are going to have like one device, and you're going to put two functions at the same time. From compatibility perspective, there is a matrix and there is a link where you can check, okay, which version from DNA Center perspective needs to match which version of vManage, what versions needs to be on iOS from iOS 60 perspective, and so on and so forth. And we strongly recommend to use this stuff because this is what we test, and this is what we can assure, from quality perspective, this is all good. So what we are going to do, we are going to build the site where one single device is going to act as both SDA and SD1 border. Here, current mode of operation is that we don't support existing SDA. Yeah, so this is for new sites only. So the idea is that first you will bring the router and connect it, I would say, to the cloud. And then when this guy is up and running, only then you'll be able, I would say, to onboard and create SDA. Yeah? So this is not for existing sites, this is for new sites. And this is something that you need to be aware of, because you cannot put this mode of integration for the existing sites. How to do it? Before integration, the router, again, because now we are talking about the router itself, the router needs to be known by SD1, so you can onboard it as in traditional methods. And then you start to integrate. Yeah? So first you integrate the software. How you do it? You go to Cisco DNA Center. There is vManage tab. You go configure. You specify credentials like IP address, things like you need to approve the certificate, you need to specify like the password and so on. And then after clicking, basically you're good to go. Yeah. So it's like 3 clicks, and both orchestrators are fully integrated. So it's relatively simple. As soon as you will do it, you will get new type of transit, which is called SD1. So that will be this intent of having this SD1 transit will be created automatically, and you will find it on the list of the existing transit from DNA perspective. Next, what you'll find from SD-WAN perspective is that integration will pop up because we just integrated the controllers. And if you go to administration integration management, basically you'll find the DNAC on the list. And here you will be able to add additional devices to the solution. So because you may have like 10,000 devices in SD-WAN, but you would like to enable this integration of SDA only for example, 1,000. So here where you are going just to pick which devices you are going to enable for integration. You move it from left to the right. And as soon as you will do it, these devices will automatically appear in DNA Center. So from that moment on, you will have these devices appearing in DNA Center. Initially, it may be some kind of weird state. It could be like reachable, it could be managed, non-managed, and so on and so forth. This is because this device is not yet fully configured. But as soon as you move forward, generally this will be mitigated. And this is one of the warnings that you will see that in order to move CH to managed state, you need to perform one of action. Yeah, like DNA Center need to know credentials. Yeah, generally that's long story short. Yeah, you need to provide the password, SNMP stuff, and so on. So you can either assign it to the specific site which has credentials already configured, or you just update router credentials like one by one. And then, as soon as you update the credentials, the device will end up in the managed and reachable state. This is, again, the device is well known and well managed right now from Cisco DNA Center. It's well known and managed from SD-WAN perspective as well, and we are good to go. Coming to the questions about how we can connect these VNs with VPNs. In this mode of operation, we are going to do it directly from Cisco DNA Center. So if you go to the provision SD access, you'll be able to select each and every VRF, each and every VRF, and then specify to which VPN ID is going to match. So this is our macro segmentation. Yeah, we are going to say, okay, user VN is going to be connected with VPN 10 or 20 or whatever. Next, you will enable from, and this is the recent thing we introduced, from SD-WAN perspective, we also will need to enable manually CTS propagation on the tunnel interface. Yeah, so this we need to assure that the packet is going to forward the SGT tags end to end, and this is something that we need to do on VPN 0 interface in order for the device to take this header and add it into IPsec header. Going back, I would say, to DNA, we have the router already, I would say, managed and configured. It's kind of in quite good shape. Now we would like to kind of create SDA network. And for SDA, what we recommend is to do it through LAN automation. Yeah? So we would like to first onboard the device. So we're going to use traditional LAN automation process. There is nothing fancy here. The main difference is that our seed device is going to be the router. So this is our like SD-WAN CH, which is going to be seed device. That will kind of allow us to bring any device that's connected to it through LAN automation process. What's important here is that communication needs to happen from infra VN. Yeah? So if you think about new device that you connect to a SD-WAN network, eventually this device will need to be able to have IP reachability to the Cisco DNA Center. There is no magic, IP reachability needs to be there, and therefore you need to assure like this infra VN subnet that you match here. The infra VN you match, for example, with VPN 100. There will be connectivity within this VPN 100 into Cisco DNA Center. Because for LAN automation, basically that's a requirement. Yeah, you need to have IP connectivity end to end. Other than that, the whole process is exactly the same. One caveat, as of now, we don't support multicast in SDA in this mode. So this checkbox is going to be grayed out. But other than that, the process is very standard, and basically, you can onboard new devices. And here you can see an example, like LAN automation was successful, one device has been completed, and you can see that this single device, like the Cat9K, has been added to Cisco DNA Center through PNP, full LAN automation, and you can manage it and you can start to configure SDA. And SDA, again, you configure it in standard way. The edge, as usual. The other box is going to be control border. This is also the SD-WAN border, of course, because we are talking about one box solution. And because of that, it will automatically have the transit as SD-WAN transit. So you don't have to do anything. DNA Center will figure it out, everything for you. It will add this transit and assure from configuration perspective, everything is in sync and it's up and running. So how to validate it? So, because we are talking about one device, which are now acting as a SDA and SD-WAN, because this is integrated solution, yeah, you can check the configuration is good, right? So from Lisp perspective, this is the, I would say, SDA part of the configuration. We have the Lisp interfaces, we have VNs created, and so on and so forth. And here you can, from VRF perspective, you see that's VPN ID from SD-WAN perspective. So we have VPN ID 10 is being attached to this instance ID from SDA perspective. So this is how you can check from, I would say, the device perspective, what's the mapping between this kind of macro segmentation that we were talking previously, right? So this is VPN IDs from SD-WAN perspective, and this is corresponding instance ID, like for example, 4102 for SDA. Yeah, and similarly, you have like one for 100 is underlay. So our infra VN, you can see it's loopback 0. So this is the loopback that's going to be configured on the box, and basically, like this is the way how you can check the mapping. So basically that's it, yeah? It's not very difficult to create this integrated solution for SDA, SD-WAN. As you can see, first you need to do it on the software layer, just a few clicks to integrate vManage and DNA Center. And then from network perspective, generally everything is happening automatically, right? So there is not much that you need to be bothered, unless you will get some issues, yeah? And if you get the issues, let's now go to troubleshooting. And I will cover network troubleshooting part. So this is something that I will not talk about the problems with provisioning, this kind of stuff. If you are interested in this area, there were some breakouts that also cover these elements in the past. I will fully focus how it works from the network perspective. So our scenario is going to be the following. Yeah, we have one site which is independent domain. So we have two devices. This is our manual configuration that we did initially with Cisco metadata. And we have the other side which is integrated. Yeah, we have one device which is acting both. Right? So I will show you an example where we have two solutions, and we'll try to see how to check connectivity end-to-end between our desktop and our IP phone. So this is in more details. As you see, from integration perspective, this is our Cisco TrustSec part that we do manually for site 1, because this is independent domain. And this is our integration area for integrated domain, because everything is happening on one single device. So that's full topology. We'll focus mainly on these two areas, but I will show you step by step how you can basically investigate and troubleshoot issues starting from the control plane, then data plane, and then security plane, so that you have all the, I would say, awareness how all of that is working in the system. So first, let's start with some kind of awareness, what's connected and how it's connected. So we have our desktop connected on the left. It's standard SDA, so it will belong to some VRF, some VLAN, IP address, and so on. If you take a look at the configuration here, I configured the statically HGT5. So whatever packets will come from this desktop, we're going to tag it with 5 and send it over marked with 5, right? And we're going to do an enforcement at the end after going through the whole path. You can see, from this VLAN basically match specific verb. Lisp is enabled because this is how it works from SDA perspective. I would say this is traditional configuration. It's good to know, like what IP addresses, what VRFs, what HGT values are used. If we take a look at the other side where we have IP phone, I use tag number 8, right? So on one side I have tag number 5, on the other I have tag number 8. I will show you how exactly to troubleshoot this kind of communication between the desktop and IP phone in this kind of scenario. So let's start first with the control plane. So control plane, why control plane first? Because first we need to know where to send information, and only then we'll have data plane and we'll be able to send the real packets, right? So control plane I will check from the end, because like I will be sending in packets from the desktop to IP phone. But the information should be first, from control plane perspective, propagate, I would say, from the IP phone, the subnet, up to the desktop, so that desktop will know, okay, that's the path to go to the IP phone. So let's start, I would say, from the end. So our IP phone with IP address 192.168.110 is going to join this SDA. It will send ARP, DHCP, standard process, nothing fancy here. Eventually, this endpoint is going to be registered in device tracking database. So you can see, the IP address from ARP perspective. I didn't use DHCP, it's just ARP. And you can see that this is well known, I would say, subnet locally. If you double click further, this prefix should be registered now in Lisp, right? Because we are talking SDA, we are talking Lisp. And from Lisp perspective, first we'll check in which instance we are looking at. So we know in which VRF this endpoint is connected to. So I can check which Lisp instance we are talking about. So it's 4102. And then I can check from database, so our local information from Lisp perspective doesn't contain the prefix or not. Yeah? And I can see it does. It contains the prefix and this kind of local. Yeah? So this is locator. So this is where the prefix is connected. And basically this is our own loopback 0 IP address. So far so good. From this perspective, information about IP phone has been registered to Lisp, yeah? Which is good. And that's all what we wanted, right? If you move to the next device, this is our border. So now we are on this box. So first of all, from Lisp perspective, the prefix should be registered in the map cache database. So like we should know that this prefix is known by the control plane. And then if you take the map cache, the entry, you can see negative cache entry because there is not yet any traffic going to the endpoint. But generally, the Lisp will know it and will know how to resolve it. Yeah? So that's all what we need. And then if you double check the configuration, you can see that all the site registrations on this box are going to be automatically added to the RIP with the administrative distance of 252. So eventually what you will see is that this specific information about the IP phone on the right will be known by Lisp, and that will be in the show IP route table, right? So this is all you need, right? So this box knows how to reach IP phone. It will just send through this interface. This guy also knows because of this entry, right? It will know that it's known by Lisp, and you can see also that this prefix will be redistributed to OMP. So we are sending this data out to SD1. Now let's move to the other side. Yeah, so we just crossed the whole SD1 through MP. We are on the site number 1. On site number 1, we have our router. You can see we successfully get the information about IP phone through OMP. It's known through OMP. And we are going to send it to BGP. Yeah, because here we are talking independent domain. So BGP is our glue between SDA and SD1. So here all is good, yeah, because the site number 1 gets information about the prefix and is going to send it to BGP. You can always check the BGP status. If we send, you can see like I'm checking if we are like advertising this specific route to SDA border, and you can see yeah we do yeah. All is good. We are sending the packet. So from this perspective, this box is all good. We can move next to the SDA border. And on SDA border, we can check again, show IP route, nothing fancy here. We can check, okay, this prefix now is known through BGP. Yeah. So up to this stage, all is good, right? Initially, we registered IP phone. It was registered, device tracking was there. We put it in the Lisp on site number 2. It was propagated through OMP to site number 1. Then BGP, and we landed on this specific border, and we have this specific entry. This is where I would say the things start to get interesting, because this guy is our default border. And because it's the default border in SDA, we are not going to propagate this route further, because default is going to attract all the prefixes to it if SDA is not aware where to send the packets. So if we move to SDA edge, this SDA edge is not going to know the prefix. Yeah? And this is expected, and this is expected only in a scenario where you do have default border and not internal border. Instead, this SDA edge will have information that for this kind of funny subnet, all the packets needs to be encapsulated to proxy TR. And proxy TR in our case is of course the border, right? So we can say from this angle perspective, this edge is also good from control plane perspective because it will know that the packet should go to the SDA border, even though we don't have /32, right? And we don't have it because we are using default border and we are using this kind of encapsulating to proxy TR functionality in order to stitch control plane together. So this is how you can check basically the control plane, right? Step by step, like redistribution to like Lisp, then OMP, then BGP, and then again Lisp, right? So I have 3 protocols to take care of in order to make it happen. Let's now move to data plane. So from data plane perspective, if control plane is good, then we can start pump the packets, right? We can start send, for example, pings, and the desktop itself is starting to send the pings to IP phone. How to troubleshoot if data plane is good? I will show you 2 tools. So first is embedded packet capture. And this is what you can do in order to understand if the real packets get to a specific place, or it was dropped or redirected somewhere else. Yeah? You never know. So the good thing about EPC, and this is something that you can use on Cat9K devices, is that it's kind of single line, right? So you specify, okay, you would like to enable monitor capture on this specific interface. I'm doing that in out direction. So I expect packets to go out of this interface. And I would like to match on this specific IP source, IP destination. That's the buffer start, and I would like to start. Yeah? So very simple, like one single CLI in order to make it happen. That will tell you exactly when I start it, and I will send some test packets. I will see if any packets has been received or not. So very nice tool to see what's out there. But the information that you get the packets, I would say just the beginning, because you would like to see what kind of packets it's going to look like, right? So I can display them. You can see it's ICMP, very simple packet, from our 10.10, which is our desktop, to 110, which is our IP phone on the other side. You can get the dump. Of course, you can do the details, whatever you want. But if you get the dump, you can put it into Wireshark. Yeah? If you put it in the Wireshark, you will see, because we are now, let me remind you, we are on SDA border, and we are doing the capture on this integration area. So we would expect all of this kind of data to be transferred further. And this is what you will see. Yeah? So you will see Cisco metadata header. You can see value of 5. And this is exactly what you would expect. Because the configuration, when I show you the configuration here, I statically configured SGT value of 5. And this value was propagated through VXLAN. It reached Cisco metadata. And eventually, it will end up in the Cisco metadata header. So you are good. You can see the IP addresses are exactly the ones that we are looking for. You have all the packets and so on. What's kind of tricky is that you don't see VLAN, right? So where VLAN is, right? There should be VLAN, because we do macro and micro segmentation. Yeah? Micro segmentation is our SGT. Macro segmentation should be VLAN. But VLAN is not here. That's kind of limitation of the platform, frankly speaking. And this is something that you may expect to see when you do the packet capture on the egress direction. If you do it in ingress, everything you will be working fine and you will see everything. If you do it on egress, then how the feature works. Generally, the packet at some moment of time is being punted to CPU. And in this specific scenario, the punt is happening before we add the VLAN, right? So I'm showing this specific example to make you aware that not everything that you will see may be the final version. For example, the MAC addresses, you can see also here the broadcast. This is, of course, it's not going to be sent as a broadcast. It's going to be a unicast. But the packet was captured for EPC before the MAC addresses were finally tweaked, yeah? Because we do it on the egress. Yeah? We don't do it on the ingress. We do it on the egress. How to overcome this problem? You can always use span, and then you will get everything you want. You can also use other tools. And the other tool is called Show Platform Forward. And this is a very nice tool because it will show you all the internal details, what is happening from the ASIC perspective with the packet. So we are talking about the data plane. Data plane is all the hardware. We never, the packet will never go to CPU. So we are relying on ASIC capabilities to run various stuff. And how to check what ASIC is doing? You first do the monitor capture, so exactly the same stuff that I was showing before. And then you do this kind of magic command where you specify, okay, you would like to get information from the hardware where the ingress interface is 108 in this case. And you would like to understand, okay, what the hardware will do when the packet will come on this interface. And the packet is going to look like as frame number 1 from this pickup. Yeah, so you're going to take, okay, dear ASIC, let me know what you would like to do with the packet if it will reach on this interface. And it will tell you something like that, right? So you will see information about input packet details. So you can see it is ICMP, it has IP addresses and so on and so forth. And you will see also output packet details. Here you will see that this packet is going to be VXLAN encapsulated. Conscious of space, I didn't put like all the frame here. But you can see here, this is the outer encapsulation for VXLAN. You can see the packet on the output has been fully encapsulated and sent over to SDA border. So yet another method that you can use in order to understand what exactly is happening with the packet from data plane perspective. This is on the switches. On the routers, it's a little bit different because the switch is different box, routers is different. Switch we use like ASICs. Here we use a different way to handle packets in the hardware. And we have also a different tool. And the tool is called packet trace. But the good thing is that the methodology is exactly the same. So we are going to basically get the packet. We are going to copy the packet, and that's the max size that you can do. You can specify the interface, and you can specify the filter. Yeah, and you are going to say, okay, on ingress interface, this packet is going to arrive on this specific interface. So long story short, the idea is very similar. Only the syntax is a little bit different. Currently, we are working on unification of these two. So soon, in the next versions, you will see exactly the same CLI. But as of now, when we are talking about SD-WAN troubleshooting, packet trace is the method to understand what's happening from the data plane perspective. But as mentioned, yeah, idea is exactly the same. Yeah, you specify you would like to copy the packets. You specify on which interface, what's the filter, and which direction. Yeah, is it kind of coming to this interface or leaving the interface? And in the output itself, you will see that first of all, very high-level summary. Okay, the packet has been received on this interface. It's going to be sent out on 000. That's our VPN 0 interface. It's going to be forwarded. Then you will find a lot of information, like internal state, that we in TAC generally look at to see that everything is good. From your perspective, probably the more interesting things will be the packet copy in and packet copy out, because this is where you can exactly see how the packet is going to look like before and after. So before, you can see the packet has arrived, because we are talking about this integration area here. It arrived with this VLAN 2001. It arrived with CMD header of value 5. So you can see everything ideally, what exactly the packet is going to look like. And then you can see the out packet. Yeah. So this is the output packet after putting IPsec, metadata, and so on and so forth, all the headers. And you can see, for example, the source destination. This is going to be our VPN 0 IP address of our site, our local site, and the remote site, right? You'll not see a lot of extra information if you can start to look at, because the packet is encrypted, right? So it will not decrypt for you automatically. But from the headers perspective, you can see exactly how the packet looks like and what the device is going to do with that. So that's the main two tools that you can use from data plane perspective. Yeah, you can use packet captures, you can use show platform forward, and you can use the packet tracer. So assuming from control plane all is good, From data plane, all is good. The last plane that is left is security. Yeah? So let's assume the packet is going end-to-end. The SGT values should be kept from one SDA through SD1 to the other SDA. And we would like to assure from enforcement perspective, everything also is working as expected. So where to start? You start from Cisco Data Center. You would like to understand what are the policies and how you enforce the traffic from micro-segmentation perspective. So here you can see an example where I create the policy to deny packets between contractors and developers in both directions. Yeah? So when source is contractor and destination is developer, I put like block, deny, and the other around, right? So the packet should be basically dropped in both directions. So that's from DNA center perspective. What you can do here, I would say common mistake is that people don't click deploy, and then they kind of, okay, it's not working. Why? Because kind of, people tend to forget to click the deploy. Also, it's always good to refresh because you would like to fully understand what's the latest state of the table, and is it really the table that you intended to have, or maybe someone else changed it, and so on and so forth. So this is the way how you will do it from Cisco DNA Center perspective. You will just create the contracts. I created very basic ones with deny, but generally, yeah, this is the standard stuff. You can do whatever you want, right? You can specify more advanced policies, like with copy, with anything else that you will come to the mind. But that was DNA Center. If you go to ICE, ICE is going to be in read-only mode, yeah, because everything is controlled from Cisco DNA Center. ICE is going to have the table, but this table is going to be read-only. But you still can double-check if everything has been successfully propagated from Cisco DNA Center to ICE. So that's the first step. Yeah, you need to assure all the APIs there are like no problems whatsoever, and ICE itself will know that deny IP is between contractor and developer, because it's going to be ICE who is going to contact with the devices and program them. It's not going to be the DNA Center, right? ICE is our like security brain in the solution. So even though we configure all the policies, everything on DNAC, this information will be automatically sent to ICE, and then ICE is going to push it to network. You may think, like we didn't, coming back to the question, we didn't have integration, I would say natively, between SD1 and ICE. In this solution is not required because all the classification, marking, and enforcement is going to happen on SDA. At this stage, I'm not showing the example where you do anything on SD1, because at the end, it's not really required, right? If you have SDA on both sides, you can assure enforcement will happen from security perspective on SDA itself. If you have information on ICE, then ICE should push it to the network, right? This is the way how it works, yeah? DNAC to ICE, ICE to the network, and the network is going to enforce the stuff. So what you need to do and assure from troubleshooting perspective is that you have CTS pack correctly available on the switch. So you can see here if you do show CTS packs, you can see this pack was coming from ICE, and basically you have the information. You have the basically OPAC of the pack itself. And why it's critical? Because pack itself will allow you to download full environmental data. Yeah, so you will get all the information about all the tags, all the policies, everything from ICE to the device. And if you do show CTS environment, you will see that like from environmental perspective, you can see current status is complete. All is good. This is IP address of ICE in this case, and generally you can see all the tags, right? So ICE is going to push the information about the policies, but the tags themselves are going to be well known by the device. In my example, I configure them statically, so they'll be local. But if you use, I would say, typical approach, which would be .1x or map or anything like that, of course, that's going to be ICE who will send the tag at the end, right? Long story short, what you would like to assure is that for this specific IP address, this one, of the host, you will get the SGT value known by the switch, right? Because if it will know the value, it will be able to add it to VXLAN, propagate it to SD-WAN, and then enforce it at the end. So this is on the source. Similarly, if we move to the destination, the same logic should apply. How to check everything is good from troubleshooting perspective? From edge, we assure that the TAC is known, environmental data is good, and so on. Life is good. From SD-WAN perspective, the only thing we need to assure is that the propagation is enabled. Yeah, because nothing will happen on SD-WAN except TAC propagation end-to-end. So here we can see, the CTS is enabled on the interface facing the SDA, and then on this interface towards the cloud, SD-WAN cloud, we can see, it's also enabled, and we also propagate it. Yeah, this is exactly what we are looking for, and this is what assure that the TAC will be sent end-to-end from security plane perspective. So now if we move to the second side, because so far we're kind of looking on the first side, yeah. So quick recap, the packets from this guy was coming. We had the value of 5. This value of 5 was added to VXLAN. It was handled over to the border. Here we carried it over through Cisco metadata. This guy propagated it further to the other side, right? So this value was basically sent over from one side to the other side. And on the other side, it gets to this guy. This guy would just forward it into VXLAN. But the whole enforcement will happen on the egress. Yeah? So the packet will flow the whole way up to the other side, up to the final SDA edge. And this is where we are going to do the forwarding. And this is where we are going to do enforcement from the security plane perspective. So in order to make the enforcement, you need to have 2 tags, right? Because the policy was contractor to developer, right? So contractor could be 5, for example. Developer could be 8, or the other round. 5 is contractor, 8 is developer. So you need to have these 2 tags in order to enforce the policy. Yeah? So the question could be from where these tags will come from. One will come in the packet itself, because the value of 5 will be basically propagating from SDA to SD-WAN and then to SDA. So that's our source tag that will propagate it all the way up to the end. The second tag will be local to this IP phone. So here we can see the value of 8, because 8 was configured statically on this interface. And now we have 2 tags. Yeah, we have tag 5, which was coming all the way from the first site. And we have tag number 8, which is local to this guy. And now we can start to enforce. Why we do it on egress? Because from TCAM perspective, from the way how you can optimize resources, this is the most optimal way to handle this. And here, if the pack is there, if environmental data is there, it means that the policy that we push on DNAC to ICE has been also propagated to the network itself, right? So from this perspective, we fully program the hardware, and we specify the rule that from between contractor and developer, we are going to deny it. Yeah? So this is our enforcement policy that will tell us, even though control plane was all good, we checked BGP, Lisp, OMP, everything was good. From data plane perspective, all was good because we do the packet captures, show platform forward, and so on and so forth. Security plane still come to the picture, and it can start drop the packets, even though the drop shouldn't be there, or it could allow the packets, even though it shouldn't allow, and so on and so forth. How to check the packets were really dropped? This is the easiest way is to just take a look at the counters. Yeah, so I'm kind of here asking, okay, dear switch, tell me, what do you think about this correlation between from tag number 5 to tag number 8? Yeah, so if the packets will come, what are the current statistics and what happened with these packets? And here you can see that, okay, from 5 to 8, all the packets has been hardware denied. So generally they were dropped, right? So control plane, all good. Data plane, all good. Security plane, we see that we had the intent to block the packets. The intent flew from DNAC to ICE to devices. And here device basically executed the intent and we drop all 100 packets in the hardware itself, this packet will never get to the final destination. And this is only possible because we integrate DNAC, so we integrate SDA with SD-WAN, right? Without this integration, the TAC will be lost. Without this integration, let me maybe go back here on topology, just to give you a full picture. What we have SDA. We have one SDA here, one SDA here. So we have like HQ and site. We have SD-WAN in between. If we don't integrate it here and we don't integrate it here, then there is nothing that can happen from security plane perspective. Yeah? The TAC, even though if we add TAC here, the TAC is going to be lost here, right? Because we don't have the vehicle in order to move this packet forward. Similarly, even if we configure this part, but for example, we don't use the integrated domain on the other side, the TAC is not going to be propagated, and therefore will not be able to enforce it on the far end. Yeah? So only by using this SDA to SD-WAN integration, we'll be able to enforce security, and basically that's the main goal, right? So from security perspective, DNAC to ICE to network enforce, and network allows you to double check what exactly happened. Yeah, was it like permitted, like software permitted, hardware permitted? If you have like monitoring mode enabled, you will also see the counters here. If you just don't want to kind of enforce it, but you like to monitor the behavior, you will see the counters here. But typically, for the any hardware things, you will just check, okay, this is the tag that was coming from the far end in the packet. That's our local tag, like destination SGT, and this is the packets that were dropped. Cool. So in summary, what I showed to you was two integration methods. So one was independent domain, and independent was where we didn't do much. Yeah, like from orchestrator's perspective, they were fully separated. We just do the CMD kind of manual stitching to make it working. I also show you the integrated domain, and this is like one single device where you integrate the orchestrators, where you integrate all the functions from one single device from SDA and from SD-WAN. And the good thing is that we do provide two documentations which shows you in much more detail how exactly to configure it and how exactly you can start from the scratch and finish with fully working integration end-to-end in both these modes. Yeah? For integrated, we have the documentation guide which will show you exactly how to build it. And from independent perspective, we have separate guide that also will guide you how to do step-by-step this configuration and make it happen. And what's kind of important is that you can mix and match these two solutions together. Yeah? It doesn't mean that whole network needs to be integrated or whole network can be independent. Yeah? As we show in the example, I show you the scenario. One site was this type, the other site was the other type, and everything was working fine. And basically, there were no issues with this kind of dual mode using in one single network. That's all I wanted to share with you today. If you are more interested in troubleshooting specifically SDA and SD-WAN in general, I would recommend to go to these sessions that are very specific to SDA and very specific to SD-WAN. Today, I'm more focused on this kind of integration piece, but to double click on this list for MP and so on, you can nicely refer to these sessions here. And basically, that's all. So thank you a lot for joining, and yeah, good luck with the integration of SDA and SD-WAN. Thank you.